Example 3, we've been given the function this time, and we're going to be asked to find the area using left-hand Riemann sums. And we have the area between 0 and 1, and we're going to divide this into 4 intervals. So the first thing I'm going to do is just make sure I know what my delta x is. It's going to be my interval width of 1 divided by 4. Okay, so we're going to end up with an interval width of 0.25. And we're going to sum this up from x equals 0 to x equals 1. And the function that we're going to do this under is under 1 half e to the 2x. So we're going to take a left edge area for each of these and then multiply that by our delta x, which in this case is 0.2. Okay, so to take the sum here, I'm going to take the left edge. That's going to be my first interval. And I need to divide this up into 4 equal parts. Okay, so this is approximately somewhere around here. That's going to be halfway here. So these are going to be our rectangles that we're going to work out. And the first rectangle, I'm going to take the height at, in this case here, the height is going to be at 0. So e to 1 half, e to the 0, and then times that by 0.25. Plus 1 half times, in fact, since the 1 half is constant, what I'm going to do is I'm just going to factor that 1 half out to make it a little bit easier to work with. So factor the 1 half out. Okay, just going to group this a little bit better. So the next term is going to be the next height is going to be at 0.25. So it's going to be e to the 0.25 times 0.25 plus the height at 0.5 times the width plus e to the 0.75 times the width again. So this represents the areas of each of those rectangles. There's 4 rectangles that we've calculated, and we're going to then sum this all up. When we sum this all up, we're going to end up with this whole sum equaling 1.692 units squared. And this area that we've summed up, okay, which I'm going to shade in red, this area that we've summed up here, is this an over or under estimate? So by looking at the curve, we can kind of see that the area under this curve, because we chose the left edge, we are missing bits of area in here. So this is going to make the red area, an underestimate of the actual area because we're missing that yellow area in there. So this is an underestimate. Okay, And this is a left-hand Riemann sum. In this particular case, it gives us an underestimate. Now, if we move the edge to the right, you can kind of imagine if I use the right edge Riemann sum, we would be using these rectangles, and those rectangles would actually end up being overestimates. Now, it's not just the fact that it's a right edge versus left edge Riemann sum. It's the fact that using a left edge, when it is sloping up, it will be an underestimate. And then the opposite will be true for the right edge Riemann sums.